Hi students, welcome back to another section. Here we are going to discuss the first exercise of this chapter. Well, exercise 6.1. So let us move to the question. The first question is, what is that? What will be the unit digit of the squares of the following numbers? What they are asking? They have given some numbers here. Well, the first number is 81. And what they are asking to us, what will be the unit digit of the squares of the following number? So, to find out the unit digit of the squares of this number, what we have to do? We have to find the square of this number. Well, so 81 square we have to find out, and we have to find out the unit place digits. Well, so when we are finding 81 square, we know 81 into 81, 1 into 1, 1, 1 into 8, 8, 8 into 1, 8, 8 into 8, 64. So when we are adding 1, 16, 1 carry, 5, 6, we are getting this one. And what will be the unit digit? We are getting 1. Is it needed to do like this? Do you think? Actually, its answer we got now. Is this number square? Is this number's unit digit is 1. Unit digit is 1. We are getting answer. Is it needed to do like this way? No. Why? Yes, we have learned the properties. Well, so we know if this number square, this number square's unit place should be, how we can find out? Yes, we need to consider only this number's unit place digit, that is 1. Therefore, this number's square's unit place should be 1 square, that means 1 itself. We can conclude like that. No need to do in this way. Got it? And let us consider the second question. It's what is that? 2, 7, 2. This is a number. They are asking to us what will be the unit place digit of the squares of this this number. So we have to find the squares of this number first, and we have to check what will be the unit place of that number. Is it needed? No. Check what we have to check the unit place digit of this number. Add its square, we know 2 square, that should be 4. So that 4 should be the unit place digit of the squares of this number. Yes, hope you understood. Well, let us check some more questions. Well, what about third question here? Yes, the number is 7. The number is 799. 799. What will be the unit place digit of the squares of this number? So what we have to do first? We have to consider the unit place digit of this number first. And check, see here, unit place digit. Yes, what about unit place digit here? That should be 9. Therefore, is square we know. What is that? 9 square, that is 81. Well, so the this number's square's unit place should be 1. So we can say like that. So the unit place of the squares of this number should be 1. How we are getting? We are taking the unit place digit first, and that is 9. A square we are calculating. By mentally we can calculate that. It should be 81. So its unit place is what? That is 1. That should be the unit place of the squares of this number. Then what about next question? Yeah, next question is 38. 3853. 3853. Yeah, this number's squares unit place digit we have to find out. So what we have to do first? Take the unit place digit here. Yes, what is unit place digit? Unit place digit, here it is 3. So we need square of this unit place digit, that should be 9. Therefore, we can say that this number's square's unit place should be, unit place digit should be yes, 9. Should be 9. Why? Because its unit place is 3. Therefore, the squares of this number's unit place should be its square. Well, so that should be 9. Hope you understood this kind of question. Let us move to the next question. Well, so what is the next main question? The following numbers are obviously not perfect square. Give reason. Yes, that is question. See here, the second question. The following numbers are obviously not perfect squares. Give reason. So how we can find out? Yes, we have learned some properties. Well, the first number, let us consider the first number. What is that? 1057, right? 1057. This is a number. They are saying it is not a perfect square. Why? It's not a perfect square. Obviously, yes. What's the reason? Yes, we know the properties. Its reason is what? Yes, this number ends with 7. We have already learned the perfect square numbers never end with 2, never end with 2, 3, 6, so 7, 8. Yeah, this we have already learned as a property. The perfect square number never end with 2, 3, 7 and 8. Well, therefore we can say this is not a perfect square number. The reason is end with the digit 7. Therefore that's the reason why it's not a perfect square number. So what about second? Yes, that is 2, 3, 5, 3. 2, 3, 5, 3. Yes. Why? What is the reason? It's not a perfect square number. What's the reason? Yes, the same property here. This end with 3. Yes, end with the digit 3. The perfect square number never end with 3. So consider the third question. What's the question? 2, 7, 2, 7, 9, 2, 8. 7, 9, 2, 8. Here also the reason is what? Yes, you said it. That is only the reason. End with, yes, here end with 8. End with 8. End with the digit 8. Well, let us move to next question. Yes, here also reason is same. End with the 2. Yes, here end with 0. But they are asking what they are saying it's not a perfect square. What's the reason? Yes, let us check the question number fifth sub question. So why that number is not a perfect square? Yes, what is that question? Fifth sub question. Yes, 64000. 64000. They are saying it's not a perfect square number. What's the reason? So see here, it's end with 0. Those numbers end with 0 may be a perfect, but that reason is not suitable here. But we know the perfect number, the number end with 0. To check whether it's a perfect square number, what we have to do, we have just count the number of zeros. If the number of zeros are even, then it may be. But if the number of zeros are odd, it should not be. So here we got it's not a perfect square number. The reason is what? The number of zeros end with is what? It's equal to 3. Therefore it's odd number of zeros. So with reason we can write it as end with odd number of zeros. Zeros. End with odd number of zero. That's why it's not a perfect square number. Yes. Another question here. Yes, it is same as end with 2. Here it is. The reason is same as end with odd number of zeros. Here it is the reason. It's not a perfect square number. The reason is end with only 1 0, odd number of zeros. Well, now let us move to the third question. What is that? Third main question. The squares of which of the following would be odd numbers? Yes, the third question. The squares of which of the following numbers would be odd numbers? Yes, we have learned the property. Which property? Yes, the squares of odd number always odd. The squares of the even number is always even. So we can use that property here. The first question, 4, 3, 1. What will be the squares of this number? Yeah, we know it's an odd number. Well, let's check the unit place digit. It's an odd number. Therefore, we can say altogether 431 is an odd number. Definitely, its squares also odd. Well, by using that property. And what about second? 2826. Yes, this numbers and this is an even number. Yes, its squares also even. Its squares also even number by using that property. What about third? 777, 9. So this numbers is an odd number. Therefore, its squares also odd. Then what about the next one? 828004. Yeah, it is an even number. Therefore, its square also even number. So what is the question? The squares of which of the following would be odd number? So we got to order this one. Yeah, this one. Yes. Therefore, the answer is for 431 and 7779. The squares of this number should be odd number. Hope you understood. Let us move to next question. See, here is a question number 7. What is that? Without add, find the sum. Without actual adding, without adding, find the sum. Let us check here. Yes, here we have learned the pattern that the sum of the first odd natural number. How we can find out? Yes, that is what that is how many numbers are there, its square, its answer. So we have learned a pattern. So here we can say the first question, 1 plus 3 plus 5 plus 7 plus 9. We need to find the sum. So no need to add by as usual addition. Right? What we have to do? First we have to check how many numbers are there. 1, 2, 3, 4, 5. There are 5 numbers. So its sum should be what n square. That means 5 square. It should be 25. So we got answer. Well, then what about its second question? So that is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Yes, we know these all are the odd numbers. The sum of the first n odd numbers. So here also we have to find out first what about the number of n. So here let us check how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, there are 10 numbers. N value 10. Therefore, the sum should be n square. So n is 10. Therefore, 10 square. The sum of this number should be 100. Well, now consider the third question. What is that? Yeah, this is also follow the same pattern. So the third question, 1 plus 3 plus etc. plus 23. Yeah, its solution. We know how many odd numbers are here. Yes, here there are, let us check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 odd numbers are there. The value of n equal here 12. Therefore, we can say the sum equal to n square. That means 12 square. What is that? 144. So without actual multiplication, by using the property, we are getting answer. Hope you understood. Let us move to the next question. See, here is also the same. What is the question? Express 49 as the sum of 7 odd numbers. Yes, by that property. So we can say 8, 49. Yeah, 49 we know it is 7 square. So we can write first 7 odd numbers. 1 plus 3 plus next odd number 5, next odd number 7, next odd number is 9, next odd number, what is that? 11, next odd number 13. How many? 1, 2, 3, 4, 5, 6, 7. Yes, so when we are adding these all, we will get 49. Yes, so this is what about second one? The second one is what? 121. We have to express as the sum of 11 odd numbers. So what we have to do? Yes, just like this. We know 121 is 11 square. Well, so the 11 odd numbers which start from where? From the very first odd number 0. Sorry, from the very first odd number 1. So we can write it as 1 plus 3 plus 5 plus 7 plus 9 plus next one is 11 plus 13 plus 15 plus 17 plus 19. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We needed one more. So 21. When we are adding these all, we will get this one. Well, hope you understood. Now, one more property, very important property here. That is, there are two n non-perfect square numbers between the squares of the numbers n and n square. What does it say? Yes, let us consider two numbers. Well, we already discussed that, I think so. So there are two, we can consider 5 and 6 the numbers. What about 5 square? We know 5 square equal to 5 into 5, that is 25. Now 6 square, we know what is that? 6 into 6, that is 36. These two are the consecutive numbers. Okay, so they are saying there are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. N and n plus 1, that means consecutive numbers. Squares, consecutive numbers. So we have taken two consecutive numbers 5 and 6, and its squares is 25 and 36. We know in between this 25 and 36 there is no perfect number. There is no perfect square number. All are non-perfect number, non-perfect square numbers. How many are there? Just to get, yes, let us find how many non-perfect square numbers are there in between that. So let us write that 26, 27, 28, 29, 30, 31, 32, 33, 34 and 35. These are the non-perfect numbers between these two numbers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers. So what they are saying, there are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. So 2n, what is the value of n here? Here the n value 5. So we can say the numbers are 2n. That means 2 into 5. Yeah, we are getting 10. So here also 10 numbers we got. So when we are getting the question like that, how many numbers are the non-perfect square numbers are there in between the squares of the consecutive numbers, we just need to do in this method, right? Let us consider some more examples, then it will be clear for you. See here, yes, here the question, how many non-perfect square numbers are there in between the squares of 11 and 12. One question is like that. So how we can find out? Yes, by using this we can easily find out. How? Solution. Here the n values is 11 and n plus 1 values is 12. Well, n and n plus 1. We know the equation, but there are 2n. Therefore, the number of non-perfect square are 2n. What is 2 into n is 11. There are 22 numbers in between this. We just need to do this when we are getting like this question. Well, hope you understood. So let us wind up today's section. Thank you.